Welcome to Shader Graph Basics, Visualizing Unity Game Effects, a comprehensive guide for beginners looking to master visual effects in Unity. Today, we'll explore the fundamentals of Shader Graph, a powerful node-based editor that allows you to create stunning visual effects without writing a single line of code. Understanding shaders is crucial for game development, as they define how objects look, react to light, and interact with their environment. Shader Graph simplifies this complex process, making it accessible even if you're new to programming or graphics. First, let's ensure you have the Universal Render Pipeline, or URP, installed in your Unity project, as Shader Graph is built upon it. If not, you can easily add it through the Package Manager, which is found under the Window menu in Unity. Once URP is set up, we'll create our first shader graph. Right-click in your project window, select Create, then Shader Graph, and choose URP Lit Shader Graph. This action generates a new shader graph asset and opens the Shader Graph Editor, presenting you with a blank canvas. The Shader Graph Editor is where all the magic happens. It's a visual programming environment where you connect nodes to define shader properties. Let's start by adding a color node. Right-click on the canvas, type Color, and select it from the menu. Connect the output of the color node to the base color input of the PBR master node. Now, if you change the color in the color node, you'll see the preview sphere in the Shader Graph Editor update instantly. This real-time feedback is one of Shader Graph's most powerful features, allowing for rapid iteration and experimentation. Next, let's introduce the Texture 2D node to apply an image to our material. Add it the same way you added the color node. Drag a texture from your project window onto the Texture 2D node's texture slot. Connect the RGBA output of the Texture 2D node to the base color input of the PBR master node, replacing our previous color. You'll now see your texture applied to the preview sphere, demonstrating how easily you can incorporate visual assets. For more control, let's add a tiling and offset node. This allows us to adjust how the texture repeats and positions itself. Connect the UV output of the tiling and offset node to the UV input of the Texture 2D node. By adjusting the tiling values on the tiling and offset node, you can make the texture repeat more or less frequently. Similarly, modifying the offset values will shift the texture's position across the surface. Now, let's explore how to add some dynamic effects. We'll create a simple pulsating color effect. Add a time node to your graph. This node outputs the current time, which is essential for animation. Next, add a sine node. The sine wave is perfect for creating smooth, oscillating movements. Connect the time output from the time node to the input of the sine node. The sine node will now output a value that smoothly oscillates between -1 and 1 over time. To make this useful for color, you need to remap these values. Add a remap node. Connect the output of the sine node to the input of the remap node. Set the in-min max of the remap node to -1 and 1, and the out-min max to 0 and 1. This remapping converts the sine wave's output into a range suitable for color intensity, from black to white. Now, let's blend this remapped value with a color. Add a multiply node. Connect the output of the remap node to one input of the multiply node. Add a color node. Choose a vibrant color and connect its output to the other input of the multiply node. Finally, connect the output of the multiply node to the base color input of the PBR master node. Observe the preview sphere. It now pulsates with your chosen color, fading in and out smoothly. This simple setup forms the basis for many dynamic visual effects, from glowing objects to flickering lights. A helpful tip for beginners: organize your nodes. Use group nodes to keep related nodes together and add comment nodes for explanations. This practice significantly improves readability and maintainability, especially as your graphs become more complex. Another essential concept is properties. These allow you to expose values from your shader graph to the Unity inspector. To create a property, click the plus button in the Blackboard panel of the Shader Graph Editor and choose a type, like color or flow. Drag the newly created property onto the canvas. It will appear as a node. You can then connect this property node to any input in your graph, such as the color input of our multiply node. Now, when you create a material using the shader graph, You can adjust the pulsating color directly from the material's properties in the inspector. This provides artists and designers with easy control over visual effects without needing to dive back into the shader graph itself. Let's save our shader graph by clicking the Save Asset button in the top left of the app. To apply this shader, create a new material in your project window, then assign your shader graph to its shader property. Finally, drag this material onto any 3D object in your scene to see your custom visual effect in action. You've successfully created and applied your first dynamic shader using Shader Graph. Remember, Shader Graph is incredibly versatile. You can create effects like dissolve, outlines, water, and even complex atmospheric scattering. Experiment with different nodes, combine them in creative ways, and don't be afraid to break things to learn how they work. The Unity documentation and community forums are excellent resources for further learning and troubleshooting. Practice is key. The more you build, the more intuitive Shader Graph will become. Consider exploring nodes like Fresnel effect for rim lighting, noise for organic patterns, and lerp for smooth transitions between values. These nodes open up a world of possibilities for unique and compelling visual effects. Remember to always save your work frequently to avoid losing progress. And don't forget to optimize your shaders for performance, especially on mobile or lower-end platforms. Thank you for joining us on this journey into shader graph basics. We hope this tutorial has provided a solid foundation for you to start creating your own amazing visual effects in Unity. Keep experimenting, keep learning, and unleash your creativity. For more tutorials and advanced techniques, subscribe to our channel.